So, in the previous lectures, we have seen the methods for production of plane polarized light by using a single optical crystal called as a polarizer. A polarizer function is to produce the plane polarized light. When ordinary light is incident on it, the transmitted light is plane polarized light. Now, we have to detect, check whether this light is plane polarized or not. And for that purpose, we are using one more optical crystal, but it is called as an analyzer. It analyzes, it tests, it checks whether the light from the first polarizer is the plane polarized or not. So we have seen that experiment of or arrangement of combination of polarizer and analyzer. So unpolarized light is incident on polarizer, light is transmitted through it. This is incident on second optical crystal called as analyzer, and by rotating the analyzer we can detect the plane of vibration of the plane polarized light. So what is the result? When the axis of the polarizer and analyzer are parallel, then light passes through it. When axis of the polarizer and analyzer are perpendicular, then no light passes, no light emerges. So by rotating the analyzer, we can detect the plane of vibration. So if in this position there is a zero light, it means that the light coming from P1 has a electric vibration in this direction. जिथे इंटेन्सिटी झिरो होईल त्याला परपेंडिक्युलर डायरेक्शनने इथले इलेक्ट्रिक फील्डची व्हायब्रेशन असणार आहे. So we can detect the direction of the electric vibration in a plane polarized light. So polarizer polarizes the light, it produces the plane polarized light, and analyzer detects the plane polarized light. It detects the vibration, direction of electrical vibration in the plane polarized light. So we have seen this experiment. त्या experimenta एक conclusion शेवटी आपण दिला होता. When these two axes are parallel, then transmitted light has maximum intensity. When they are perpendicular, the intensity of the outcoming light is zero. So by rotating this analyzer, we can control the intensity of light. So that intensity control is the main role of the polarization phenomena or polarizer analyzer system. So last time we have seen two crystals are used. First is polarizer, another is analyzer. If only a single crystal polarizer is used, it also reduces the intensity to half. So what to prove this? So for that purpose, a separate question is given in our notes, and that question is like this. Question: show that the intensity of the unpolarized light intensity of unpolarized light means ordinary light or circularly polarized light, unpolarized light reduces to half. Reduces to half after passing through polarizer. So what to prove this? For example, by figure we can show like this. If this is a polarizer, this is the incident light having intensity I0, this is the transmitted light intensity I1, then I1 is equal to I0 by 2. So by 2, show that if I0 is the intensity of the incident light incident on the polarizer, then the transmitted light has intensity I1 and it is half of the incident intensity, like this. So what to prove this? तर या ठिकाणी आता इंटेन्सिटी रिड्यूस होते हे तर आपल्याला माहिती आहे, कारण काही व्हायब्रेशन्स कट होतात. ओनली व्हायब्रेशन्स पॅरलल टू द ऑप्टिक ॲक्सिस, polarizing axis of the polarizer are allowed to pass through. Remaining remaining vibrations of the electric field are stopped, they are absorbed, and therefore transmitted light will have intensity always less than I0. So it becomes exactly half. Why? So we can prove this. So same figure we are using in detail like this. So I will draw the same diagram. Suppose this is a but to show this, I1 is equal to I0 by 2. So I will redraw the figure like this. So this is a polarized. This is a polarizing disc. This is the optic axis, polarizing axis, like this. This is the x-axis. Wave is traveling in x direction. So this is the unpolarized light. So it can be shown like this. It is a circularly polarized light. Like this. This one electric vibration I am showing by red color particularly. So this is a unpolarized light, intensity I. After passing through the polarizer, we get a plane polarized light. So we are considering this only one ray shown by red color. So this is polarizing axis, y-axis. So this angle is phi. This angle is phi. So this is E, like this. This is polarizer. It produces the plane polarized light. This is polarizing axis. Polarizing axis. So this is also polarizing axis, like this. So this intensity of the transmitted light in the direction phi, making an angle phi with the polarizing axis, is I1. So we have to show that I1 is equal to I0 by 2. So the wave is traveling in the x direction, positive direction. साउंड सिस्टम मध्ये आपण प्रोग्रेसिव्ह वेव्हचे इक्वेशन बघितलेले आहे. द जनरल फॉर्म ऑफ द इक्वेशन इज y इज इक्वल टू a sin ओमेगा t मायनस r प्लस kx. त्या टर्म रिव्हर्स पण करता येऊ शकतात आपल्याला. kx अगोदर पण घेता येऊ शकतो. सो यू कॅन राइट दिस इक्वेशन y इज इक्वल टू a फॉर एम्पलीट्यूड sin of kx plus or minus omega t. So for the wave traveling in positive x direction, we use the minus sign, lag-behind action. So the wave is traveling in this direction. Consider a light wave traveling, propagating in positive x direction are represented by the equation of the progressive wave is like this. E is equal to E0 for amplitude into sin of kx minus omega t. So this is the question 1. The wave is represented like this. So consider a light wave traveling in positive direction, having electric field E. So E0 is equal to amplitude of wave incident on polarizer. Where what is the remaining term? K is equal to 2 pi upon lambda. It is called as a wave vector. Omega is equal to 2 pi n is equal to circular motion मध्ये पण या क्वांटिटी यूज केलेला आहे. angular frequency. It is also called as the angular velocity. N is equal to frequency of light wave. It is also frequency of oscillating electric field. We know the properties of the electromagnetic wave. Oscillating electric field. Electric field and magnetic field both are oscillating fields. They are alternating field. Frequency of oscillating magnetic field both are having same frequency, same phase. Like this. Lambda is equal to wavelength. Wavelength of a wave. Now, from 11th standard, we know that any type of wave, mechanical, non-mechanical, transverse, longitudinal, the intensity of the wave is always directly proportional to square of its amplitude. This is the general characteristics of any type of wave, mechanical or non-mechanical. So, if you use this property, then this I0 can be given by, since for any wave, intensity is directly proportional to square of its amplitude. Square of its amplitude. Therefore, if I0 is equal to this I0 is equal to intensity of incident unpolarized light, then I0 is directly proportional to E0 square. This is equation 1. E0 is the amplitude of the wave and I0 is the intensity. So intensity is directly proportional to the square of the amplitude. This is equation 1. Like this. Now, let us see about the transmitted wave. Now, we have to find the value of I1. So I1 is the intensity of the transmitted light. It is a plane polarized light, like this. So, in this figure, we are considering one of the incident electric field vector shown by this red color. Consider a particular wave having electric field E inclined at an angle phi with polarizing axis. This. So, E cos of phi component is parallel to optic axis. Therefore, it is E cos of phi, and therefore it is transmitted. It is transmitted through polarization. So I will show you. If you draw perpendicular, then this component is E cos phi. And now, if we draw perpendicular on x-axis, this is the sine component. This is the sine component. Sine component is completely absorbed. E0 sine of phi. So this amplitude is E0, making an angle this, and this is the E0 cos of phi. So E0 cos of phi is transmitted. E0 sin phi, but E0 sin phi component is perpendicular to optic axis. Therefore, it is absorbed completely that only E0 cos of phi is passing through this. Let I1 is equal to intensity of transmitted light for this particular wave where therefore I1 is directly proportional to E0 cos of phi bracket square. This E0 cos of phi is nothing but the amplitude. So for incident wave, amplitude is E0. For transmitted wave, for this wave, it is E0 cos of phi. So this is E0 square cos square phi, where variable phi has values 0 less than phi or equal to less than 180 degrees. So phi is variable, therefore cos of phi is variable, therefore I1 is variable. So if we consider this angle 0, 45, 90, 135, 180 like this, then this amplitude, therefore intensity of the transmitted light will also change here. So we will consider the average value. Let I1 is equal to average value of transmitted light, therefore it is equal to average value of this is equal to average value of E0 square cos square phi. So E0 is constant value, therefore it is equal to average value E0 multiplied by average value of cos square phi, and therefore I1 is directly proportional to E0 square into 1/2. तो cos square phi sin square phi या दोघांचे ॲव्हरेज व्हॅल्यू जर आपण 0 to 180 डिग्रीसाठी जर कन्सिडर केलं तर त्या 1/2 येतात. सो दिस इज इक्वेशन सेकंड. You can write this value cos square phi from 0 to 180 degree is equal to 1/2. Average value of sin square phi from half cycle 0 to 180 degree pi radian is equal to 1/2. हे मॅथमॅटिक्समध्ये आपल्याला प्रूव्ह करता येतं. इलेक्ट्रोमॅग्नेटिक इंडक्शनच्या चॅप्टरमध्ये आपण या व्हॅल्यू पुन्हा यूज करणार आहोत. Average value of sine function over one complete cycle is 0. Average value of cos function is 0. Average value of cos square phi is 0. Sorry, 1/2, etc. like this. So we can prove this one. Integration by parts आपल्याला यूज करावं लागतं. So this is equation second. So equation 1 and 2. Now if we divide these two equations, divide 2 by 1 gives transmitted intensity upon incident intensity is equal to 1/2, and therefore the transmitted light has intensity 1 half times incident intensity. So intensity reduces to half. So this property we are using directly, but we can prove in mathematics. So average value of cos of phi from 0 to 180 degree is equal to 1 half. Cos of 0 is 0, cos of 90 is 0, cos of 0 is 1, cos of 90 is equal to 0, and cos of 180 is equal to minus 1. But there is a square. So cos square 180 degree is also 1, like this. So I1 is equal to I0 by 2, like this. So this, in this figure, this factor is very important. आपण फक्त ह्या एका कॉम्पोनंटची इंटेन्सिटी काढली, असा कुठलाही कॉम्पोनंट घेऊ शकतो की तिथे फायची व्हॅल्यू चेंज होईल. आता या प्रॉपर्टीचा यूज आपल्याला न्यूमेरिकल प्रॉब्लेम सॉल्व्ह करताना पण करायचा आहे. If I0 is the intensity of light incident, unpolarized light incident on the polarizer or any optical crystal, then transmitted light has intensity always half. The transmitted light is a plane polarized light. Remaining vibrations are absorbed. This E0 sign component is absorbed completely. Only the E0 cos of phi factor is transmitted and it produces the intensity I1. And that intensity is I1 is equal to 1 half of phi below, like this. So while solving the problem, you can use this property directly. असे नंबर ऑफ पोलरायझर ॲनालायझर आपण यूज करू शकतो. प्रत्येक वेळेस इंटेन्सिटी हाफ ऑफ होत जाईल ती, लक्षात. Suppose this is a polarizer P1, this is a polarizer P2, this is a polarizer P3. So their axes are parallel. So if the incident light has intensity I0, then the light transmitted from P1 is I1. The light transmitted from P2 is having intensity I2. The light transmitted has intensity I3. So if three polarizer have their axis parallel, then by this rule I1 is equal to I0 by 2, I2 is equal to I1 by 2, याच्या निम्मे जाईल. So that is equal to I0 by 4. I3 is equal to I2 by 2, याच्या निम्मे इथे होऊन जाईल. So this is equal to I0 by 4 multiplied by 2, that is equal to I0 by 8. The intensity half जाईल. I0 by 2, I0 by 4, I0 by 8. But this is the condition. All the three axes must be parallel to each other, like this. याच्यातला एक जरी आपण पोलरायझर टर्न केला 90 डिग्री मधून, तर इथलं इंटेन्सिटी I2 0 होऊन जाईल. आणि ह्या दोन पोलरायझिंग ॲक्सेस मधला अँगल महत्त्वाचा आहे, म्हणून मी याला हायलाइट केलेलं आहे. सो इफ द two axes are not parallel, what will happen? If axis of two polarizer are not parallel, then what will happen? हा प्रॉब्लेम मी का सांगितलं त्याचं कारण लक्षात. इफ द ॲक्सेस आर पॅरलल, दिस इज अ सिंपल रूल. इफ इंटेन्सिटी इज I0, देन दिस इज इक्वल टू हाफ I0 by 2. ही त्याच्या अजून निम्मे झाली I0 by 4. दिस इज इक्वल टू I0 by 8. बट इफ द ॲक्सेस आर पॅरलल, बट इफ द ॲक्सेस आर नॉट पॅरलल, देन व्हॉट विल हॅपन? सो दिस आन्सर वॉज गिव्हन बाय द सायंटिस्ट Malus. तो Malus लॉ आपल्याला या ठिकाणी माहिती पाहिजे त्यासाठी. If the two axes are not parallel but they are inclined like this, then what is the transmitted intensity? That's what you see. like this. So now let us go for Malus law. It is a very important law. So before going to the explanation of Malus law, let us first know the limitation, that is the important part. Limitation for Malus law. It is applicable only when the incident light is plane polarized light. It is applicable only when light incident on a polarizer is plane or linearly polarized light. This is the limitation. It is applicable only when the light incident on the polarizer is a plane or linearly polarized light. Now, this is the polarizer P, and this is a linearly polarized light. It is shown like this, having intensity I1. Then the intensity is I2. So I1 is equal to I incident intensity, I2 is equal to IT. So IT is equal to transmitted light has intensity, IT is equal to intensity II into cos square theta. ह्या थीटाचा मिनिंग काय तो आपल्याला क्लिअर करायचं. It is a unpolarized light. Unpolarized light, plane polarized light. So this condition is satisfied for P2. So I1 is equal to incident intensity for this P2. So this theta is equal to, the meaning of theta is important, where theta is equal to angle between the two polarizing axes. So same figure we can draw in another way like this. So this is the first polarizer. This is the optical axis. First polarizer. This is the second polarizer, and its axis is like this. Second polarizer. Polarizing axis. So this incident light is unpolarized light. Unpolarized light is shown like this. It is a symmetrical distribution of electric field vibration. Like this. So unpolarized light. Unpolarized light. This intensity is I0. This intensity is I1. And this intensity is I2. So this I1 is equal to I in our figure. I2 is equal to IT. And this angle between the two polarizing axes is theta. So the intensity is I1, so electric field has amplitude E1. This electric intensity is E2. Same figure अपन कर लेंगे. Hello sir. So these electric vibrations, it allows the electric field vibration in this direction. It allows the electric field vibration in this direction. So this value will be definitely less than this, like this. So if this is I0, then I1 is equal to I0 by 2. I1 is equal to I0 by 2. Just now we have proved this. When unpolarized light is incident on the polarizer, then the intensity reduces to half. आता याच्यापेक्षा इथे किती असेल इंटेन्सिटी ती आपल्याला व्हेरीफाय करायची आहे. So the situation is like this. So this is the Malus law. So I have not given the statement in bold, but you can remember the bold the statement like this. So the main point is this limitation. It is applicable for plane or linearly polarized light. So incident light for the polarizer must be plane polarized light. This is unpolarized light. First polarizer would polarize it. It will produce the plane polarized light from unpolarized light. It is incident. So if this intensity is II, this intensity is IT. I for incident intensity, IT for transmitted intensity. So IT transmitted light has intensity II cos square theta. Theta is the angle between the two polarizing axes. तर इथे आपण या फिगरमध्ये आपण दोन पोलरायझर असे दाखवलेले साइड व्ह्यू. इथे आपण असे दाखवलेले. सो दिस इज द ॲक्सिस ऑफ द फर्स्ट पोलरायझर, दिस इज द ॲक्सिस ऑफ द सेकंड पोलरायझर. सो दिस इज ॲक्सिस ऑफ फर्स्ट पोलरायझर, ॲक्सिस ऑफ सेकंड पोलरायझर, लाईक दिस. सो दे आर इन्क्लाइंड ॲट एन अँगल थीटा. So if theta is equal to 0, what will happen? If theta is equal to 180 degree, if theta is equal to 90, so we will consider all the cases 0, 90, 180 and between 0 to 180, like this. So we have to find this relation. So relation we already know what to prove. So this part we have already proved. I1 is equal to II is equal to I0 by 2. It is the intensity of the light transmitted through the first polarizer. So this I1 is equal to this much. Now the electric field from the first polarizer E1 is given by this is E1. So E1 is equal to electric field of light transmitted through first polarizer. And it is along the y-axis. आपण y-axis घेतला नाही. हा y-axis angle theta. So E1 is equal to E1 0 amplitude into sine of kx minus omega t into j. J is a unit vector along the y direction. So this is the amplitude. E1 0 is not what amplitude is equal to amplitude of E1 from E1 first polarizer, so we denote it by E1. Now it is incident on the second polarizer. So second polarizer is inclined at an angle theta, and therefore it has intensity I2. So this intensity I2, so E2 is given by E2 is equal to E2 is equal to electric field of light transmitted through P2, transmitted through polarizer P2, through polarizer P2. So it is inclined at an angle theta. It is inclined at an angle theta, and therefore this E2 is given by E2 is equal to E2 0. इथल्याप्रमाणे आपल्याला सफिक्स देता येईल E2 0 sin of. There is no change in propagation vector, there is no change in frequency, there is no change in direction, where this value is important. E2 0 is equal to E1 0 cos of theta. This current, if we draw perpendicular on this axis, so if this is E1, then in this direction making an angle theta, if we draw perpendicular, then this component is the E2. So this component is E2 cos of theta, E1 cos of theta. याचा component या डायरेक्शन आपल्याला पाहिजे तर तो हा येतो. So E2 has magnitude E1 cos of theta, and therefore this is, say, one more equation. So incident light is unpolarized light, transmitted light is plane polarized along y-axis E1. It is given by like this. E1 0 is the amplitude. Now, if this light wave is passed through another polarizer whose axis is inclined at angle theta with the first axis, then definitely the amplitude will decrease. It will be E1 times cos of theta. Therefore, E2 0, amplitude of E2 from the second polarizer P2. So, since intensity is directly proportional to the square of amplitude, therefore I1 is directly proportional to E1 0 square. This is equation 1. I2 is directly proportional to E2 0 bracket square. This is equation 2. So I2 is substitute this value E1 0 square cos square theta. This is equation 2. 2 by 1 gives I2 upon I1 is equal to cos square theta. Therefore, I2 is equal to I1 cos square theta. I2 is equal to I1 cos square theta. This is Malus law. Malus law, where I1 is equal to I0 by 2. Incident intensity is I0, याचा हाफ इथे होईल I0 by 2 आणि याच्यापेक्षा अजून इथे कमी मिळणार. So this value of I2 or transmitted light intensity depends upon mainly theta. या थीटाच्या आपल्याला केसेस आता देता येतील. So case number 1, this is Malus law. When theta is equal to 0 degree or theta is equal to 180 degree, then cos of 0 is plus 1, cos of 180 is minus 1, but cos square is plus 1. Then cos square theta is equal to 1, and therefore I2 is equal to I1. Case number 2, when theta is equal to 90 degree, then cos of 90 is equal to 0, therefore cos square theta is equal to 0, and therefore I2 is equal to 0. So we can control the intensity like this. There is no intensity of light. So what is the result? When theta is equal to 0 or 180 degree, means the two axes are parallel like this or anti-parallel like this, parallel or anti-parallel, and theta is equal to 90 degree means they are perpendicular. So in the experiment of polarizer and analyzer, we have seen the same observation. If the two axes are parallel, maximum intensity passes, light wave passes through it. If the two axes are perpendicular, polarizer and analyzer, no light wave emerges, I2 becomes 0, intensity becomes 0. So this is the Malus law, and these are the special cases. So theta has value from 0 to 180 degree, and for any value of 0 to 180 degree, we can get this intensity. So in this case, there are three intensities. I0 is the intensity of the unpolarized, I1 is the intensity from the first polarizer, I2 is the intensity from the second polarizer. So like this, first polarizer, second polarizer, third polarizer, fourth polarizer. For each case, we can use this equation, Malus law. It is a very important relation. I2, if only one polarizer is used, then this I1 is equal to I0 by 2, that we have already proved separately like this. Okay, we will stop here. Next time we will see the various methods for producing the plane polarized light. So remember this Malus law. Numerical problems are also asked on the Malus law.